so we can make this available at a further date. So for those of you that may not know me, my name's Cody Maxwell. I'm the Fannin County Extension Agent for Agriculture and Natural Resources with Texas A&M AgriLife Extension Service. And I must say, before we get into this, I don't know as far as the operations that are represented here. I don't know. You know, as we talk about soil testing in the first part, it's going to be generally speaking as far as soil testing itself. As we go on through the presentation, it's really going to get into the production of our forage crops. That being our pastures and hay meadows is what it will focus on quite a bit. We can get into talking about calculating fertilizers for lawns, gardens, etc. And we can certainly do that, and I can show you how to do that when we get to that point of the presentation. I just wanted to say that up front, a lot of this information that you're going to see is going to pertain to our forage crops once we get into the nutrient side of things. Get this slide to advance here. So I love this slide. Those of you that may have been watching our or listening to our podcast, I've said this saying, and there's another saying that you'll hear me say here in a little bit, but the single most important thing that you can do as a landowner, homeowner, whatever the case may be, if you have a piece of Texas or Oklahoma, if we have some of those joining us, I know a lot of our information stretches into southern Oklahoma as well, but if you own a piece of Texas, or if you own a piece of Oklahoma, or wherever you are in the United States, the single most important thing that you can do to be productive, whether that case may be the forage crops, as we mentioned a while ago, our garden crops that we have. You live in residential areas. You know, many of our HOAs, our homeowner associations, you're required to maintain a level of, I'll say productivity, but you have standards that you have to live to, that you have to abide by when it comes to what your lawn looks like. Well, how do we get a lawn to look lush and green other than water? It's through nutrients. How do we know the nutrients within the soil? It's soil testing. Going back to those forage crops, our pastures, our hay meadows, getting into the row crops, wheat, corn, cotton, soybeans, sunflowers, whatever you may be growing out there. The single most important thing that you can do is test that soil. We're going to talk about how to do that here in just a little bit. But many times, I just talking some scenarios with you, many times I get the question, well, I live in this area of the county. What do I need to put down as a fertilizer? Well, there is not a person in this world that's going to be able to tell you exactly what you can put down based on that soil. We might be able to make some guesses. We might be able to make some pretty accurate guesses, but we're not going to be able to tell you exactly how much to put, just generally speaking. You may call and say, hey, Cody, I'm growing Bermuda grass. I'm looking to produce this much hay. Well, I can, estimate how much nutrients you're going to have to make that much hay. I can tell based on your grasses that you have out there on your property, whether your soil might be in good shape or it's lacking in some things, but I don't know exactly where those nutrients lie within that soil on your property. Nobody does. Every property is managed differently. And again, generally speaking here from our ag production to things that we may see done at the home, such as the lawns and gardens again, everybody manages differently. Every property's differently. When we get below that forage layer, we can look on soil maps to determine what type of soil we might be working with. But as we go across that property, it may change. It may be different. And so the single most, if you don't take anything else from today, take this. The single most important thing that you can do on your property is soil test. So where to begin? Well, through that door right there, we have there's a nice young lady sitting right there at the front desk named Karen Biggers, and she'll greet you with a smile every time you walk in. She does a great job for us right there at the front desk. But within our office, we have soil sample forms and soil sample bags. I realize on a day like today, you're obviously not going to want to get out, and you may have some concerns of maybe not as much now, but if you have concerns of COVID and getting out, we can actually mail those bags to you. We can mail the forms to you, or we can email those forms to you with just a simple click of the button. And you can also find them yourself if you'd like to go to soiltesting.tamu.edu. You can find those sample forms on that website. But soil testing, again, most important thing that you can do, and we'll certainly work with you to get those done. So this form right here, this is actually, I forgot to change this form out here, but the form's going to look identical to this, except for the top right-hand corner. I'll bring your attention to that. We've got a laser pointer on this feature here, so you see that laser going across the screen there, but this section right here, that says S20. That's actually the wrong form for the time that we're in right now. We're in 2021. So if you go on the website, or if you come in our office, or if I email you a form, it will have S21 right there in that top hand corner. Very important to make sure that we send those forms in that are current with the year that we're in. The soil testing lab likes to receive the current forms, just in case there's any change to pricing or anything like that. You may have picked up a form from us last year or the year before, or 3 or 4 years ago, that may be sitting in the file cabinet that you, after you hearing this presentation, you're convinced that you need a soil test. That's my goal today. And you may want to send in a form from 3 or 4 years ago. Check with us, check with the website. Let's make sure we get that current form. Turn our laser pointer off here. Moving on to the next slide. We'll go through this. I don't want to spend the whole time and dwell on a lot of this. Very self-explanatory on the top part. This form here is going to be our form that we use for anything that's over an acre. If you're less than an acre, then you're going to want the SU21 form. That's going to be our homeowner and urban soil sample form, and it will be listed as such on our soil testing website. Just go through here, pretty general information. Acreage represented, sample ID, you can call it whatever you want. North pasture, east pasture, west pasture, south pasture, pasture 1, 2, 3, 4. Yeah, that's just for you right there. Acreage represented, how many acres are we working with? Really important right here on this, we only want to put 40 acres per sample. If you have 50 or 60 acres, let's divide that up into 2 samples. If you have 120 acres, we're going to be working with 3 samples. The next section here is what crop are you growing? Again, probably one of the most important sections on this form. We don't want to leave it blank. We don't want to guess. Rather than guessing, I prefer you reach out to me, or if you're in another county, a county agent that you may have in that county. Different grasses, as you'll see a little bit later on, due to production levels, are going to require different amounts of nutrients. Yield goal. If you're in a Bermuda grass hay production setting, your yield goal is going to be more than somebody in a native grass setting potentially. So our fertilizer recommendations are going to be different, and the use. You may be heavily stocked. That's going to be a presentation that we'll be coming to you with here in the near future. But are you looking to graze, for instance, a cow to every 3 acres on your place, whereas somebody else might be grazing a cow to every 10 acres? That's going to be our intended use right there. Selected analysis suite, we'll go over that here in just a second. And then how is this forage going to be used? Are you going to be grazing? Are you going to be trying to cut hay and graze on it? Are you establishing? That's key right there. We've got some people that we're working with that's establishing Bermuda grasses and native grasses this year. If you're going to be in an establishment standpoint, we need to make sure to check that box. Here's what it's going to look like on the SU21 form. This is the urban homeowner soil sample form right here. Similar, but just a little bit different. Label it how you'd like in the sample ID. The square foot of the area being sampled. If you know the last time you fertilized, if so, what with? If you don't know, just simply put NA on there. We'll talk about I'm growing here in just a little bit in the requested analysis. So this again for the SU21 form, I am growing. I'll go back to show you that section right there. I am growing, it says in the example, it says F. So we go to this slide. Well, that particular example is growing common Bermuda grass. You can see each letter has a definition of what you plan to be growing. It's grouped out by annual flowers and gardens, turf grass, and then our trees and woody ornamentals. Simply put, what you're going to be sampling for that area. For example here, if you've got one area of that yard that you're going to be doing a vegetable garden in the front, and you may have a backyard orchard in the back, we need to do 2 samples on that. So we can do one for the vegetable garden and one for our orchard. So this is that suite analysis that we talked about. As you can see, the different analysis have different prices that go along with them. As you go down through there, they're obviously not listed in price order, but the one that I've said on a radio program before, but I'll use that reference here. But I'm going to say 99 out of 100 people are going to need the routine analysis, and that's going to be that $12 per sample analysis. That's going to give you, and don't worry about this, we'll talk about it in a little bit. That's going to give you the pH, nitrogen, phosphorus, potassium, sulfur. That's what many of our fertilizers are going to be listed as. We'll explain that in a little bit. I have had some people that have wanted some detailed salinity tests and concerns of salt buildup in irrigation settings potentially. We've had very few people that have used that, but I have had some clientele that have used that. I've only had, that I know of, one producer that has used box number 7. And that will be the routine plus the micro, plus the boron, plus the lime, plus the organic matter, plus the detailed salinity, and it's an $81 test. Again, I've only had one person in my career in Fannin County, which we're going on 7 years now. One person that's used number 7. It's there if you want it and need it, obviously. So. All right, getting into actually taking the sample. And again, well, many of you have probably soil tested, but we might have some on here that have not yet. So I want to make sure that we explain this before we get into the detailed information in this presentation. So obviously the tools that you can use. We used to have a soil probe, it's actually 2 of them at the extension office. But obviously, as many of you know, when you offer things for use, expensive things like that don't always make their way back. And so we're currently in the process of trying to get some more of these soil probes ordered. We'll try to get that done and have those available for this year. But in the meantime, you obviously see that there's some tools that everybody has available: spade, sharpshooters, garden shovels. You know, many of these things work very well, work just as well as soil sample probes. So here's where we again differentiate the S21 and the SU21 forms as we get into the directions on taking the sample. If you're in a situation for pasture, hay, meadow crop, field, or a wildlife management situation, you're going to take 10 to 15 different core samples from that property. Don't just go to the good areas. Don't just go to the bad areas. Out of those 10 to 15 spots, take half from the good areas, half from the bad areas. What we're trying to do here is get an average representation of the soil across that property. Remember, in some cases, we could be dealing up to 40 acres a sample on this. And so when we just take 10 to 15 different spots, you know, we want an average representation over that whole area. And when we're fertilizing, whenever we're taking those soil test recommendations and coming in and fertilizing, we're amending that soil to bring it to a better level of opportunity for productivity. And so very important to make sure that we go across that whole property. As we take those core samples, as we drive around or we walk around the property, we want to take a plastic bucket with us. That plastic bucket can be as simple as a bucket from Fix and Feed, a 5-gallon plastic bucket from Fix and Feed, Lowe's, Home Depot, the Homer buckets that you get there, it doesn't matter. Simply just a plastic bucket that we carry around with us. And each one of those samples, each one of those cores that we take, we want to take that foliage layer. We want to take the grass or weeds or whatever the case may be. We want to remove that, just put the soil into the bucket. And once we get our 10 to 15 different areas, or if you look down there on the urban homeowner, the 8 to 10 different areas, we want to mix those up really good and get all of that soil mixed up in the plastic bucket. And then we want to put it in one of those soil sample bags that you can get from us. And then you'll send it to our soil testing lab down at College Station, as you see in the picture right there. So takes about 2 weeks, roughly. I know when we were back in COVID, things were delayed at that point in time just due to skeletal crews that we saw in offices. So it took a little bit longer earlier on last year to get those soil tests back. Try to allow for about 2 to 2.5 weeks for them to receive that and to get it processed. Many agents across the state are promoting soil testing right now. Many of them are probably giving presentations similar to what you're hearing today. So give it about 2 weeks and you should have it in by about that point. If there's not any questions at this point, I want to move into the more detailed information that we'll get into on this presentation now. So it's going to take about 2 weeks to get that back, get the soil test back. When you get it back, what do you do now? If you send in, I'm just going to use the example of if you send in 3 different soil samples on 120 acres, so 40 acres per sample. When you get an email back from the soil testing lab, they'll send you an email, or you can pay $2 extra, as you probably saw on that form, to get a paper copy back. You're going to get 3 sheets of paper back. And if you've never looked at a soil analysis before, you might look at it and you might think, well, it's quite confusing. That's what I did when I looked at my first soil sample, and second and third, until I figured out how to read them. We're going to explain to you in this presentation how to read those soil tests. We're also going to talk about here in a little bit what the nutrients provide to plant growth and development, and which nutrients are the most important to us. That's what we're going to explain to you. But before we do, the only quote that I can take credit for in I guess my 34 years, I gave it away, my 34 years of being on this earth, there's the only quote that I've actually wrote down, and I'll take credit for right there. Soil, it's the foundation of your agriculture success. This has been the theme that I've wanted to base 2021 on. as far as our programming efforts. It's obviously always been our theme, but I was just in the first radio program of the year that we did. It was just randomly talking on there, and this came out. And it's when you sometimes when you say something so you can remember it, you want to make sure you write it down. Well, it came out, and as I was recording, I paused the recording at that point in time, and I wrote this down, and I said, that's as we go through every presentation that I give this year, every development of every webinar and program that we do, this is going to be the basis behind it. It should be the basis of your operation. It should be our focus in everything that we do, agriculturally speaking. Soil, the foundation of your agriculture success. It's literally, we talk about taking things from the ground up. Well, there it is, literally right there. We unless there's bare spots, we really can't see the soil unless we dig it up like we're doing on a soil test. In some cases, if you've got a good forage cover out there and you've never tilled your soil, or if you've never taken a soil test, or if you've never dug up some of the soil, some of you may take some soil test and look at it and say, oh wow, I didn't realize it looked like that on my particular property. But literally, when we talk about building things from the ground up, you go back to establishing grasses. You go back to looking at the yield potential that we have with some of these grasses. You look at the yield potential in some of your garden crops, your sweet corn that you may be growing, your tomato plants that you may be growing. If that soil is not proper, if it's not in a state that's going to be desirable for those plants, whatever the case may be, to grow, it's basically going to be all for naught. If I could remind everybody, if you can, unless you have a question, if you could mute your mics. We're getting a little bit of background noise right now, so maybe check your mics and just make sure you're muted there. But soil is going to be the foundation of our success on our property. So as we move forward here, here's a chart with a lot going on. and we'll go through here mainly the top portion of this as we break our nutrients down into three categories. We're going to have our primary, our secondary, and our micronutrients within that soil. So we start off with the 6 primary, and you see the first 3 on there. And obviously we as humans, us as producers, we have no control over those top 3: carbon, oxygen, and hydrogen. Carbon is obviously taken up as carbon dioxide in those plants, and it makes up 45% of that plant. You can read through here, and we'll have this presentation available. If you'd like a copy of this presentation, send me an email and we'll get this to you. But very, very important chart right here. As you go down to oxygen and hydrogen, obviously, again, we have no control over that. We realize that 2 hydrogens bonded onto an oxygen is going to be water. And the good Lord above is the only one in control of that. If we're in a dryland crop situation, if you're in an irrigated situation, obviously you've got a little more control over that rather than the rainfall that we receive. The functions of oxygen and hydrogen is respiration, energy production, plant structures, pH regulation. We're going to talk about that in detail here in just a little bit. Water retention and synthesis of carbohydrates. Moving down to those next 3 in the primary nutrient category: nitrogen, phosphorus, and potassium. You're going to hear as we talk about soils a lot related to these 3, because in a fertilizer blend or fertilizer formulation, the 3 numbers that you see listed on there are going to go back to nitrogen, phosphorus, and potassium. If you see 4 numbers, That fourth one's going to be sulfur on there, as you see listed down in the secondary category there. Percentage of the plant that nitrogen, phosphorus, and potassium makes up is extremely small as compared to the other three that are in the primary nutrient category. But whenever we go over to the major functions within the plant, you can see these three are extremely important as they relate to plant growth and development, and also the quality of that plant. Specifically there, as we look at nitrogen in the major function in the plant, protein and amino acids. I'll talk just briefly on that right now. We'll spend more time later on in the program as we talk about how protein, how nitrogen relates to crude protein values whenever we look at our hay, whenever we look at that grass that's out there. When we're lacking in nitrogen, or if we're deficient in nitrogen, those of you that are feeding cattle right now in this lovely weather, it's quite fun, I must tell you, and every one of you that are doing it can relate to it as well. Hopefully you've got hay set out already. But when we look at that hay that we have, hopefully you've done a forage analysis or a hay test on that hay. But there's going to be a value on there called crude protein value. Now, when we look at nitrogen, we're obviously talking about the actual, it's the protein and amino acid development in that plant. When we go back to how it's represented in a forage uptake form for livestock, it's in a crude value. And how we get that crude value or that crude protein is we take the protein in the plant, so the protein value times 6.25, and that gives us the crude protein value of that plant. If you've ever wondered what crude protein means, there it is right there. That's how we define it. Nitrogen value times 6.25 is the crude protein value. So going back to the hay producers that are on here with us and the livestock producers, when you're lacking in nitrogen, then your crude protein value is going to be low in that forage that you're providing, whether it be the grass on the ground or the hay that we're feeding right now. So when you're low in that and it doesn't meet the nutritional requirements of that livestock species, we have to supplement. And I don't know how many of you have looked at our commodity prices here lately. You listen to Ag 30 this week and you'll hear it. But our commodity prices are on the rise. Crop farmers have got to be sitting there just grinning from ear to ear for the prices that are there right now and that they might be able to capitalize on in the futures market for 2021. You go back to the livestock producer and they've got a frown on their face whenever they're looking at those prices. So I say all of that to go back and put this in a practical setting for us. If we sell ourselves short on the hay that we're feeding out there or the forage that we have to then bring ourselves into a supplementation state, which is more money out of our pocket. Forage is, you'll probably think, well, why'd you just show that slide that you just showed? So we said that soil is the foundation of your success. Then we move up, building from the ground up. Forage is the next foundation of your success in terms of livestock and hay production. So spend a lot of time on that protein and amino acids right there, but I just want to talk about how important these three here, nitrogen, phosphorus, and potassium, are as they relate to plant growth and development and the quality of that plant. Moving down into the phosphorus, obviously it doesn't make up near the percentage of the plant that nitrogen does, but when you move over to the formation or the functions of that phosphorus has within that plant, cell formation, protein synthesis, fat and carbohydrate metabolism. Moving down into potassium, 1.5 percentage of that plant. Water regulation. You go back to how oxygen and hydrogen, water is so important for these plants. When we get into a regulation state, whenever we talk about regulating that within the plant, we don't have the potassium, it won't be regulated like that plant needs it to, or the enzyme activity as well. We could spend hours upon hours, as you can obviously see on this chart right here. I'll leave the secondaries for the sake of time, the secondary and the micronutrients for you to review later. And many of these, as you see, going back to that soil testing form that we talked about a while ago, as you get into the micronutrients here, primary secondary is going to be included on that routine analysis, that $12 per sample one. When we get into the micronutrients, that's when we start increasing the price of that soil test. If it is needed, though, obviously we can get in and discuss those micronutrients. So, how to read a soil analysis. Here is that form that you're going to get back from College Station when you send them a soil test. And as I said, you know, there's a lot going on here. We're going to talk about it. I'm going to take just a pause for just a second. But as you get this form back, you can see that many of the things that we have on here are what you filled out on that form. I'm going to go back to the laser here so you can follow me on this form here. Here's the county that the sample's taken from. It'll obviously ask you that on the form. This particular one was in Fannin County. Laboratory number, that section on there that said lab use only, that's what it's for. This particular sample right here, we could call down to College Station and say, hey, we need you to change the crop grown from improved and hybrid Bermuda grass for grazing to improved and hybrid Bermuda grass for grazing and hay. On this number right here, they go into that database on all the soil tests that they've taken down there. They make that change with the click of a button. It changes these recommendations here, fertilizer recommendations, to the crop grown and the use. There again, I can't emphasize enough how important filling out that form is to the specifications on your property is. Customer sample right here. This was the Middle North pasture is how this one was described. There again, that's simply for you. You can see that this person did this wrong. Area represented 80 acres, and I put this one on here for a reason, just so we can point that out. Soil Water Forage Testing Laboratory is what that stands for, recommends less than 40 acres per sample. You're probably going to get a little note back from the lab down there that's going to make sure that you knew to send in 40 acres per sample. But anyways, I just point all of this out right here to let you know that's from what you fill out. Now let's move down in here into this area that you're all here for. You can see the analysis suite. This is what we selected right here. Obviously, if we paid for more, this is going to be much lengthy down through this analysis. That's what this extra section down here is for. Here's the results. This next column here. That's the actuals. This next column, CL, that's our critical level that we want to be at. The units, this is how it's listed. For you chemists out there, you know, you're probably loving this part of the presentation right here. Parts per million is how much of that's going to be represented. Then we get into this bar graph right here. And I said, if you don't take anything else from this presentation home, take home that you need to do a soil test on your property if you haven't already. On a warmer day, we'll put that in there for sure. This is the next thing to take home. We look at that bar graph and we can understand where we are as far as our nutrients, where they lie, where we need to get to. There's a bar graph here, and I'm going to go back and we're going to explain these results in these different sections here. But here's the section right here that y'all want to pay attention to, is where do you stand as far as that critical level, where you want to be at. This section over here is the fertilizer recommendations to bring you up to that critical level. So we go back, and I hope that laser's not making you dizzy there, but we go back to this row right here. This is our nitrate. You go over and you see that the result from that soil test from this particular property is 2 parts per million of the nitrate. So we move over. Well, what does that mean? What's our critical level for the nitrate? Well, it all depends. It all depends on our level of productivity or our expected yield out of XYZ. Whatever we've got out there, our critical level that we need to get to is based on that particular plant or crop. So there again, very important, and going back to that SU-21, the Urban Homeowner Soil Sample Form, it's very important to list your agriculture practice that you're going to be doing on there, and with what type of crop, because that's going to determine how much nitrogen we need out there. Then we go over to here. If that doesn't make sense, we go to the bar graph. Well, this is extremely low for improved and hybrid Bermuda grass in a grazing situation. We've got to bring that level up. 55 pounds of nitrogen per acre is going to bring it up to here to meet our needs for the situation that we have here. Moving down to the phosphorus, there's 9 parts per million. Our critical level for phosphorus in this particular situation is going to be 50 parts per million. So we go across to the bar graph, and we're in a very low category on phosphorus. 55 pounds of phosphate per acre is going to bring that up to our critical level for this production setting right here. We'll go down to potassium. 111 parts per million. Our critical level we want to be at is 125 parts per million. It's going to take 10 pounds of K2O or potash per acre to bring it up to the critical level. That's what all those numbers mean on there. We go to another one here that we'll explain in a little bit. You've got your pH up here, and you've got limestone requirement to amend or adjust that pH that's listed right there. All right, everybody with us here? Any questions up to this point? All right, if not, we're gonna move to the next slide, which is the pH. pH, and these are 2 definitions that we see over on the side. And I'll read specifically off that screen right there on what pH is. It's the measurement of the acidity in the soil. You want to further define it, it's the measure of hydrogen ion activity in the soil solution. So basically, you know, what does that mean, or what causes a soil acidity? And here we see the environmental situations really that contribute to soil acidity. I'll talk here in just a minute about, you know, how can we assume pH levels across our county or North Texas, Southern Oklahoma area. So causes of soil acidity: parent material, leaching, and cultural. So you've got the soils formed from acidic rock, leaching, rainfall. That's our biggest cause to leaching that takes place. What leaches? Calcium, magnesium, and sodium. Then we get into those cultural things that cause soil acidity: soil erosion and the removal of crops. So what does that tell me right there? Well, it tells me if I don't have a soil cover out there, I'm running the risk of soil acidity occurring within that soil. I'm running the risk of having erosion take place on that soil if I don't have something out there covering that soil. Many of you have probably heard the technique that's being promoted much today of the no-till techniques. Many of you maybe have you may have some winter crops out there right now. You may have some winter pastures that you have planted. Some of you may put those in with the no-till drill. Well, that's some practices that we have available to us now to keep from disturbing that soil. Obviously, we know that there's cases where we have to disturb that soil, where we have to come in there and do a light disc or heavy disc, depending on what we're trying to do, or till, however you want to call it there. But if we don't have a whole lot of soil compaction, then we have this practice now of no-till practice that keeps us from disturbing the soil, that keeps us from getting into a potential opportunity of having soil erosion. Well, I told you we were going to talk about how do we differentiate soils across Fannin County. You could say Grayson County for that matter too, probably Lamar County, possibly a little bit of Red River County if there's any of those joining us here today. In Fannin County and Grayson County specifically, Highway 82 that runs east and west across those counties is really our dividing line that divides our alkaline soils from our acidic soils. It goes back to that parent material right there, soils that are formed from acidic rock. Well, we ask the question, well, what soil is formed from acidic rock? And the answer is sandy soils. So going back to, and you might be sitting there thinking of what part of the property or what part of the county do you live on or that your property's on? Look at Highway 82 going down the center. If you're south of Highway 82, if you're in Collin County and you may be joining us on here, if you're in Fannin County and you're close to Collin County, if you're in the Leonard Trenton area, moving over to the southeast corner of the county, you get over into Ladonia, Pecan Gap area, south of Honey Grove, all of those areas south of 82 are going to be more of our alkaline type soils. Those are going to be those soils that have a pH level of above a 7.0. Now moving to the other side of 82, moving to that north side, you get out towards Ivanhoe, Telephone, get out in Ravenna, Mulberry area. Those areas close to the Red River, the closer that we get to the Red River, the more soils that we see formed from those acidic rocks. And generally speaking, that's when we get into our sandy type soils. That's when we get into those acidic type soils. Just thinking back to soil tests that I've done, you may be sitting there thinking, well, depending on where I'm at, what should I expect my pH to be? This is the one where we can start kind of zoning in just a little bit better. Again, most important thing that you can do is soil test on your property, but just thinking out loud of where you might live at, if you're south of 82, if you're in those what we call the blackland soils, many people refer to them as that. Those are those heavy clay soils. You're probably above a 7. If you're up in the sand, you're obviously below a 7 and probably below a 6 and maybe some cases below a 5. The highest pH that I have ever seen in a soil test in Fannin County has been an 8.9. That was the highest that I had ever seen. And it come from down in the Trenton and Leonard area, right around in there. Again, don't go off of exactly where you live at. Do that soil test to know exactly. The lowest soil test, or the most acidic soil that I have seen in Fannin County was right up on the Red River, and it was a 4.3. That's the far extremes that you'll see. I would say the range, when we bring it back down to that range from the far north end to the far south end of the county, you're going to be about a 4.5 from the Red River up to about an 8.5 when you get down to Collin Hunt County area, down in there over to Delta County. About an 8.5 is as high as you're going to see. Obviously, 7's neutral, on that scale. You think back to your days in chemistry when we talked about pH, 7 will be neutral on that scale for you. I'm going to check our time here as we come down to getting close to the 1 o'clock hour. And again, there is a ton of information that we can talk about on soils. I've been saying on the radio program that we could talk soils every week of the year and still not cover everything that we need to know. So this particular slide right here, how do I know if I need to adjust my pH? Here's many of your grasses that you see. I'm going to bring back that laser pointer again. So this is all of our warm season grasses right here. This is our warm season annual grasses. The top ones are perennials. These are the annuals. You've heard me say this before, and here's the chart that kind of reiterates that. We don't have any cool season perennial grasses really that are grown in our area. The only one would be fescue. We get asked a lot about perennial ryegrass, but we don't grow any perennial ryegrass in this area. Then you move down to what we've got growing that's green right now, or that's frozen right now. We see a little bit, a small amount. I know one producer that's got some backyard barley that's put in, but in terms of grazing and grain production, our biggest ones around the county will be oat, rye, and that when it says rye right there, that's referring to cereal rye. Then we have our ryegrass, our annual ryegrass, triticale, and then our wheat. You move over to this next column right here. That's the pH range that we have available to us. So when we look, Bermuda grass can withstand a pretty large range of pH, a 5.5 to an 8.0. It loves alkaline type soils and it loves acidic soils. It's widely adaptable, you would say, for our North Texas, Northeast Texas region, Southern Oklahoma as well. Bahia grass. Some of you may have never seen Bahia grass before. If you're in the Blackland soils, I haven't seen hardly any of it in the Blackland soils. I have seen some, but you're going to see more of Bahia grass whenever you get into those more acidic type soils, obviously with the target pH of 5.5 to a 6.5. They all love Dallas grass. You know, many of you have probably asked me the question before on how to get rid of Dallas grass. I'm going to go to the chat here. Where is buffalo grass pH? We'll get to that here in just a second. So back to the Dallas grass. It's one that all of you in the lawn situation, you absolutely hate it. Those of you in a hay production situation, you obviously hate Dallas grass. Those of you in a cattle situation or livestock situation, and you don't have anything else out there, you might love Dallas grass. Obviously, we have some concerns with it when it gets into the latter part of summer and into fall. We have an ergot toxicity that will develop in the seed head of that Dallas grass. Therefore, we have to keep a watch on our livestock to keep them from ingesting those seed heads that can cause the ergot toxicity within them. But you can see it's widely adaptable, as well as every single person on this call knows that Dallas grass is widely adaptable. Johnson grass, one that some of you may have on your property, it's kind of like Dallas grass. If that's all you got, you learn to live with it and love it and learn how to manage it, and it'll be your best friend. In other situations, you know, we're trying to eradicate it and get rid of it. Cline grass, we don't have a whole lot of that around our area. We do have some, but not a whole lot. And again, we're talking about them, but we're focusing on the pH as we move to the right-hand side of my screen, probably yours as well on the target soil pH. Native grasses. So the question was asked to me directly, where does buffalo grass fall on the pH scale? That's going to be right here in the native species. it can tolerate about a 6.0 to an 8.0. If you're in the acidic type soils, probably not so much. But if you're in the moderately acidic, and kind of referring back to that soil analysis, we had those different categories: extremely low, very low, moderately low, and then the critical level. If you're in a moderately acidic setting, and it'll tell you that on the pH up there, in parentheses, buffalo grass will withstand that. And then obviously moving up to our more alkaline, our blackland type settings, it's adaptable there as well. Native species, what does all of that entail? Well, just kind of give you an idea: big blue stem, little blue stem, Indian grass, switchgrass, side oats grama, eastern gamma grass. That's going to buffalo grass. That's going to include those native species. You go right down to the next one, old world blue stems. That's many of you probably heard of WW Beadall by now. It was kind of new to us in the area a few years ago, but is becoming a little more common, or people are more knowledgeable about it now, just because we see a lot more of it in our county. It would be considered an improved plant, but many people of those old world blue stems, specifically for North Texas along this Red River, the variety that they're going to plant probably is the WW Beadall. We don't have a whole lot of love grass. If you might be joining us from Oklahoma, as we move on up into Oklahoma, you start seeing a lot of love grass up there in that area. Highly tolerable to those acidic type soils, very much a clump grass. People that try to shred this stuff absolutely hate having to shred over it. It has a massive clump down at the bottom of it. Then moving in down to those warm season annual grasses. Obviously, corn in this situation is going to be in a row crop setting or in a garden setting, 6.0 to 7.5. Moving down to the crabgrass there, one again that some people, if you're you're in a yard situation, you in Bermuda grass specifically, you probably hate crabgrass, and that's probably putting it mildly. If you're in a pasture situation and you have mixed grasses, you probably need to learn to love crabgrass. Extremely palatable to livestock, extremely digestible and high quality as well. Millets, pearl millet, brown top millet, and foxtail millet, particularly the pearl and the brown top, would be the types that we would see planted in our area. And then you get down to the forage sorghum, the sorghum Sudan hybrid, which would be what's more commonly called our hay grazers. As you can see, many of those annual grasses, the warm season annual grasses, tolerate usually anywhere from about a 5.5 up to, we could probably say up to an 8 in this situation. I know it says 7 to 7.5, but I think we can be generous and bump that up to an 8. Obviously, all of these work in our blackland soils as well. And then finally, moving down to the cool season annual grasses. Hopefully, if you have put in winter pastures, you did that a couple of months back, hopefully. If you didn't, we had a really mild winter, and I don't mean to move this into forage production talk here, but I think it's important as we go through here. Many of you may have questions on some of these grasses, specifically as it relates to soil pH. So I think it's fair to describe these as we go about. But we're in a situation now, a utilization time of our wheat and our oats and our cereal rice, specifically the big three, that are planted earlier on and utilized right now in the time that we're in during the winter. Usually December to April is the months of utilization for those three. If you don't have them in, it's too late. Going to the ryegrass there, the annual ryegrass, again, if you don't have it in, it's too late. But we were in a situation here this year with the mild winter that we had where we could continue planting that into December this year with the temperatures being very mild for us. Months of utilization aren't going to be about till March and April on the ryegrass. We would love for it to be for February for our area, But I'm afraid for this month of February, we're going to be extremely too cold to be able to utilize any of that ryegrass for our area. Probably going to be more like the middle of March on into the 1st of May, in which we'll be able to utilize that. As you can see, all of these are widely adaptable across our area. They tolerate the moderately acidic soils. It says 7.0 right there. We've got a ton of wheat, a ton of oats that's grown in our alkaline soils and our blackland soils. And as you probably well know, there is a ton of volunteer ryegrass that comes up in those alkaline type soils too. So that number needs to be changed to probably an 8 to an 8.5 for our area here in the North Texas region as we look at the different types of grasses and how they relate to the soil pH. We'll move on to our next slide here. And it's how to adjust the soil pH. We're right at 1 o'clock. And I intend for these webinars to be an hour long. And so here's what I'm going to do. I've probably got at least an hour of presenting left on this. And so what we're going to do is open it up for questions at this time. I'm going to